Okay. Welcome back from spring break. Hope you all had a good break. PS8 is out and is due near the end of the week. I was going to talk a bit about it here in a minute, so I'll put off that. And the grades for PS6 are back, although I've heard from more than one student that the testing results weren't consistent with what they got when they ran them themselves. Like twice I heard that they lost 11 more, they failed 11 more tests according to the TA than they did when they ran the test themselves. Is that, I want to see how widespread that is. Is it any? All right, so there may have been we're checking to see if there was a problem with the script that ran the test. So hopefully we'll find the problem and correct all those en masse. So I'll keep you posted. Yeah?
When are those like re-grades, I guess? When are those ones going to be due? Are they going to be extended because maybe the next other test?
Is what going to be extended?
Like, I remember the call like...
Oh, the regrade, PS6R. Yeah, I don't even remember when it's due, but yeah, I'll make sure there's plenty of time to ask for a regrade. Any other questions or problems? So we're sort of on the home stretch now. I think there's 5.5 weeks left, so not too bad. Okay, so this PS8, what I gave you was an assignment I've never given before, and it's to write unit tests for a reader, writer, lock class from .NET. So I think I had a couple ideas in mind when I did this. One was I talked with the TAs after class, last time we had class, and they told me that by and large, the students in the class weren't very good at writing unit tests. That the grades in PS6 reflected that. Maybe the grades in PS6 reflect a bug in the grading script. So. Anyway, I thought you could use more systematic practice of writing unit tests. Because for this, your code coverage, I think the problem with writing unit tests is the only measurement we have is code coverage. But code coverage isn't the only goal. Code coverage determines whether you execute every line of code, but doesn't test whether you adequately tested the specification. So for this, your goal is to adequately test the specification. And as it says in the assignment, I've given you, I wrote an interface that provides a reader, writer, lock abstraction. I gave you a correct implementation of the interface that's implemented using a class from .NET. And I gave you one that's completely incorrect in that all the methods do nothing. That's just as a starting point. And you're supposed to write unit tests that will correctly say that the correct implementation is correct. So it should pass, the correct implementation should pass all of your tests, but any incorrect implementation should fail at least one of your tests. And the way we'll grade it is by, let's say I make 50 different incorrect implementations, each incorrect in some way, 50 incorrect implementations of that interface, and we'll run your tests on it. And ideally, every time I run an incorrect program against your test, one of your tests will fail. And of course, you'd better pass all the tests with the correct implementation, because it's easy to cause a test to fail if you just have your test always fail. So there will be a big downside to your grade if the correct implementation doesn't pass your tests reliably. So be sure that you make sure that's the case. Let's look at, I gave you a couple tests to start with, so I just wanted to talk about them briefly. This first test, very simple. The idea is, so we have these reader-writer locks, and the idea is if you have a lock, a reader-writer lock object, such as right here, RW lock, you can acquire either a read lock or a write lock on that RW lock right there. Multiple readers, well, I guess what's important here is before you can exit a write lock, you have to acquire the write lock. So there's a method that where you obtain the write lock, and a method where you release the right lock. And here, there's nothing to acquire. So the specification says that if you attempt to release a lock before you've acquired it, it should throw that exception right there. So this test here really has nothing to do with multi-threading. A lot of your tests won't have anything to do with multi-threading. You just need to test standard types of things, such as the right exception. This particular exception is thrown when you don't acquire a lock before you release it. So not every one of your test cases needs to use multi-threading, but some of them do, because we're talking about locks here. So let me see if there are any questions about that first. Yeah?
Will you make lock classes that are wrong because they throw an exception with the wrong type of exception?
Sure, I might have an incorrect lock class that doesn't throw an exception in this case, or it might throw some exception that's not a synchronization lock exception.
So it wouldn't work to just do like expected exception type of exception.
Right, you wouldn't want to say expect exception. You need to be specific about what the specification says. That kind of exception is thrown. You better make sure that kind is thrown. Now, it occurs to me that what I'm asking you to do is technically impossible. Okay, why is it impossible to write test cases that will always detect an incorrect implementation? Yeah?
Proving the state doesn't exist is impossible.
Okay, yeah, you can't. Well, I'll answer it differently. You say proving something doesn't exist is impossible. I could write arbitrarily complicated bug. I could write a bug that only occurs the millionth time that you release a right lock. It forgives you if you didn't acquire it first. It doesn't throw the exception. So that means you'd have to write a test that acquires a lock and releases it 1,000,000 times. And then if I notice someone's doing it, I could change it to 1,000,000,000. So I'll be fair when we're doing the grading. I'm not going to try to create some really obscure error like that doesn't crop up very often. So we'll grade fairly. Okay. Oh, another thing to point out: put a timeout on each of your tests. I think what I said in the assignment was that all of your tests together shouldn't take more than a minute to run. Okay. And if you wonder why I'm putting that constraint in, if I'm going to run your test cases against perhaps 50 different implementations, and it takes a minute to run for each one of my incorrect implementations, that's 50 minutes just to script one of your sets of test cases. So that's long enough. So make sure that the timeouts in all your tests don't add up to more than a minute. Yeah?
Is that timing just our PS6 tests or every test that we've written so far for this class?
No, it's just PS8 tests. Yeah. Yeah, it's just the PS. Yeah, we're not worried about spreadsheet tests. But the test you hand in for PS8, make sure that the timeouts add up to a minute or less. And be sure to use timeouts. Okay, now this is a little more subtle. So with read-write locks, 2 tasks can simultaneously obtain a read lock. So multiple readers can be in the critical section at the same time. And this test is to make sure that 2 tasks can simultaneously acquire the read lock and enter the critical section. So let's see what I do. I have this variable count here. We'll see what that's for in a minute. I have this manual reset event. We'll see what that's about for in a minute. And then I create a lock object right there. I create 2 tasks right here. Both of them call the same method. So both tasks run the getReadLock method. Now, do those tasks run simultaneously? Probably. Does one run before the other? Which you think would run first? Would T1 make that call to get read lock before T2 does? Yeah?
You would think it would, but it isn't always that way.
Right. You would think it would, but it's not always that way. It can go in either order.
Which is so weird.
Yeah. Well, basically, what happens is when you create the task, it probably goes on a queue somewhere, and I can only speculate. But yeah, you can't count on them running in any particular order. And so if you find yourself saying things like, yeah, these will run at the same time, or this one will run before that one, you might be wrong. So you have to be careful about the assumptions you're making. And you could debate the assumption that I made here. So I create the two tasks, and let's see what they each do. Each executes that inner read lock. They decrement count, and then they block right here. Block means the task stops, because the task can't go until this object here is set to true. All right. Now, meanwhile, up here, my main, my testing thread is doing a spin wait. So it's just waiting. It waits for up to a second, which is far too generous. I should have used a smaller time. But it's waiting for a second to see if count goes to 0. Now, why would I expect count to go to 0? Yeah?
Because they're decrementing, they should both be
Right. Both those tasks are running. They both should be able to enter the critical section, decrement count. And if they both do that, count ought to go to 0. Okay? And so this is just waiting until this becomes true. When that becomes true, we release the block on the tasks and the test ends. So what was the reason I have this right here? Why do I block both tasks? What would happen if I took that out? Yeah?
One could get all the way through the lock, but the other one.
Right. One, it's there to guarantee that I want to know, are both tasks simultaneously in the critical section? So I know they both entered the critical section because they both executed this. See, count goes to 0 means both tasks at least got to that highlighted point. What I want to avoid is one task getting the read lock, doing all that, suppose this were commented out, getting the read lock, decrementing count, and exiting the read lock, and then the next task coming along and doing the same thing sequentially. I want to make sure that both were in there at the same time. So what I'm going to do is block both tasks so that they're not, you can't exit this critical section until the main task allows them. So when count goes to 0, before we've called MRE.set, we know that both tasks simultaneously enter that critical section. Yeah?
If you remove the exit, is that the same functionality as the wait one?
Remove what?
Remove rwlocks.exit read lock.
Okay.
Would you keep both threads reading without exiting?
Now, if I took that out, it wouldn't have any effect on the test.
Well, like, if you just left like enter read lock in for like the method, and
Yeah.
you had both those threads do the enter read lock without exiting, and you just like when those threads completed, would that technically be the same thing as having the RW lock being in a read lock?
Okay, maybe I'm not understanding.
Right.
But I mean, this releasing the read lock is a good thing to do, but it's not.
Like if I start up a thread and have it enter a read lock,
Okay, like here.
never put in the exit read lock,
Yeah.
and then I go back up to like the main thread, like with the test, and I ask like, oh well, is like one of my threads currently in a read lock? Is that gonna be like a 1 or like is it gonna read as like having a thread in a read lock?
Yeah. So yeah, basically, if you don't execute exit read lock, it's gonna think the thread is still in the critical section. Yeah. So you might do something like this. Instead of doing this with the MRE.wait1, why don't we do this? What we'll do is enter, decrement, and then we'll sleep for a while. Maybe we'll sleep for 500 milliseconds. So the idea would be the threads enter surely within 500 milliseconds. Both threads will have entered and decremented. The count goes to 0. Both tasks are still in the critical section, and the task up here will notice that the count has gone to 0 and end the test successfully. What's wrong with that? Yeah?
It'll only sleep for that amount of time and then it'll just continue resuming.
Okay, so it'll sleep for half a second. So my reasoning here would be task 1 comes in here, decrements, and sleeps. Task 2 enters before this thread is woken up. Task 2 enters, decrements, and sleeps. And before both tasks wake up, the main task has figured out that the count has gone to 0 and that they both must be sleeping by now, and that proves both were simultaneously in the critical section, so it passes the test. So this would probably work most of the time, but can you see a flaw with it? Yeah?
It depends how the sleep time you put on there, but like no matter what, it's possible for thread 1 to go in there, sleep, and then get out of the thread before the second one even goes inside of it.
Yeah. So what I've done here is set up a race condition. I'm assuming that in the first thread that gets here is going to acquire the lock and sleep, and that half a second is enough time for the second thread to get in here and start sleeping. And that's enough time for this task up here to notice that the count has gone to 0. But we're sort of depending on timing of 3 tasks. And that's, if one task is abnormally slow sometime, then the test is going to get failed. So don't make assumptions about how fast or slow things will run. And I've sort of done that here. I've assumed that a second is long enough for both tasks to get in there and set and do the decrement. So how could I clean this up? How could I avoid doing a spin lock here? How could I know for sure, without just sitting there and waiting until count goes to 0, how could I know for sure? Yeah?
You could pass in like a reference to like 2 booleans outside of the tasks, like one for T1 ready and T2 ready.
Mm-hmm.
And then when you pass in that reference to those 2 booleans, you put it into like T1 ready into the task 1 ready to not get read lock.
Okay.
T2 ready to get read lock for the second task.
Okay, let's try that. So we'll do read, he said do read 1 ready, T1 ready, and we'll say false. False.
And then have your get read lock take in a reference.
All right, well, actually, the way I'm doing it, by having get read lock be nested inside this method, they have access to T1 ready and T2 ready without even passing them as parameters. So I'll take that out. Well, then what do I got to do? I got to just sort of spin waiting for T1 ready and T2 ready go
So
to.
like after you do the interlock decrement, just
Mhm.
have it set the ready to true.
Right. But then I'm stuck here. I'm wondering, what do I do down here? I have to do like a spin wait until T1 ready is true and T2 ready is true. That sort of amounts to the same thing.
So do like a while, like T1 and T2.
Yeah, I could say while.
Run up empty loop, and then after that run the insert.
Yeah. So I could have that's again, we're spinning, but I could, it's basically like this with a infinite timeout, just waiting. Yeah, I could make that work, or we could use more of these manual reset events. So I could have a manual reset event. So this is what I had in mind. We'll create another manual reset event here. And we'll call it MRE2. And right here I'm going to say MRE2 dot wait 1. Okay, so the main task is in a block until this event is set. And down here, we're going to do the decrement, and if the result of the decrement is 0, then we're going to do a MRE 2.set. So what happens is, task 1 comes down here, acquires the lock, decrements, and finds it's decremented the count to 1, and blocks. Task 2 comes down, acquires the read lock, decrements it, and notices it decremented to 0, and so it sets MRE2, which, back here in the main task has been waiting right here. When that's set, it can proceed to release the tasks, and I guess it released the tasks. And as long as this doesn't time out, we'll pass the test. Anyway, there are lots of options, but to write the tests that actually test the multi-threading aspects, you've got to understand multi-threading. You've got to be able to visualize what's going on. For example, why would it be bad? Let me go back to the way I had it. I'll get rid of MRE2 here. Why not do this? Why not decrement count that way? Yeah?
It's not atomic.
It's not atomic, meaning what? What could go wrong? Yeah.
You could have both threads enter the lock at the exact same time and then you have this.
Right. Both tasks could be simultaneously trying to decrement count, and it's not atomic, which means you could get wrong answers in there. We've seen that before. Problem is the task has to read the number, subtract one from it, read the variable, subtract one, store back. So 3 steps. And that's happening in 2 different tasks as they get interleaved such that you get the wrong answer in there. So that's a race condition. So I never even explained what the term race, R-A-C-E, why that word? Yeah.
Because 2 or more threads are basically racing to reach the same condition.
Right. 2 or more tasks, 2 or more threads are essentially racing to see who gets to this first. And if one gets to its first and finishes it before the next one gets to it, you're good. But if the race is a tie and they execute it at the same time, then it's bad. And you might run the test 10 times and it passes, and 11th time it fails because you have a race condition. And they can be really hard to figure out. So you have to think pretty carefully about these. Make the test as simple as you can, but you got to take race conditions into account. So the topic of the lab tomorrow is debugging, using Visual Studio to debug multi-threaded programs. Because you can, when you hit a breakpoint, you got the option of you can break every task and look at what's going on in each task, or you can just freeze one task and let others run. So that'll be a useful lab to look at. Okay, so you can do, like I said, you can do a lot of this without even understanding anything about multi-threading, just testing the spec. But to make sure that the locks behave like they're supposed to, you got to get a little bit creative. Any last questions? Got a couple, yeah.
Yeah, just to confirm. So interlocked dot decrement and you pass in the reference, that is an atomic.
Right. So this interlock class provides a bunch of static methods that do common operations atomically. Now some things are atomic. So storing an int into a variable is atomic. Reading an int from a variable is atomic. If the data is long enough, though, even a read and a write's not atomic anymore. But short things like ints and bools are okay. Yeah.
Are there ways of creating like interlock methods? Like if I could define like a named method that runs a certain series of lines, and is there a way to turn that method into becoming atomic?
Well, the way you make methods atomic is with locking. That's why we use locks, is to make more complicated code atomic. Yeah.
What's the reasoning behind using the interlocked class versus just putting the right lock on?
Sure. So I could have just created a critical section here that put locks around, a different lock around the n minus minus or the count minus minus operation. It's just more convenient just to call a method to do it for you.
Is it more efficient or it's just more convenient?
Not sure. Certainly more convenient, and it's certainly no less efficient. It might well be more efficient. Don't know for sure. Other question? Yeah.
Little random, but why? So if you enter a write lock and then you do a try enter read lock afterwards, which you'd expect an exception from that. Why would it throw a lock recursion exception? Like why is recursion involved in that?
Well, recursion means the same task can't acquire 2 locks, right? So you have one task trying to acquire both a read and a write lock.
Well, I have a task that's already in a write lock, and then I have another one that's
It's a separate task trying to get a read lock in?
Yeah,
That shouldn't be a recursion exception.
that's what I'm.
I'd have to take a look. Because the recursion exception is just when when one task tries to acquire a read lock or a write lock twice on the same block. There are two constructors, only one of which you're responsible for. One constructor allows the creation of locks that can be used recursively, but we don't have to worry about that. Yeah.
Yeah, I think the documentation says that it just throws a recursion if it's already in a read mode or if it's already in a write mode. Like, so you can't be in any of them when you're in that same thread.
For the same thread.
Yeah, but he was on two separate threads, which is what
Sorry.
threw me. So I just have to take
I
a
have a
look.
question as
Yeah.
well.
Mhm.
That goes into that. What exactly is being locked? Like in the manual reset event, it's seeming to say don't do anything in this thread if it's like manual reset dot way one is don't touch anything on this thread till it's unset. But if you just put like a lock around some code, is it just saying do not execute these lines of code until this is released? Or I'm just trying to get kind of
Yeah, this is just a way of, sometimes you want a thread to stop, a task to stop until you say it can go.
Right.
And this is one case. I want to block execution of this task until I'm sure that both tasks have entered the critical section. So it's just a convenient way to stop a task in its tracks until someone else says it's okay now. Yeah.
Are we gonna have to worry about testing those recursion exceptions?
No, you don't have to worry about testing recursion exceptions because.
Yeah, that's what I thought.
Oh wait, no, I think you do. Yeah, I take that back. Yeah, because the constructor we're using doesn't permit recursive use of the locks. So yeah, that is something you can test. Yeah.
What about the disposable ones?
Yeah, you don't have to worry about the disposable method or the disposable exceptions. That just refers to, when you're through with the lock, you can explicitly dispose it, or you can wait till it's garbage collected and dispose is called for you, but we're not going to worry about that. Yeah.
Do we need to test, I guess I haven't looked at the one you wrote, but on the one that we read, there's a two-string and the other, like, generic. Do we need to test the functionality of all those, or mostly just the locking?
You have to test the things that are listed in my interface.
Okay.
Okay. So, that's PS8. Now let's look at something different. Okay, so what I have here in Visual Studio is a server. So it's a server for a to-do list service. And I'm going to run it now. And what happens by default when you start a service project in Visual Studio is it pops up a web browser and it displays a web page. So you can tell from that look at the URL up there. It says localhost : 44444. So what does the local host tell you? That's the URL of my service. That's where it's running. So where physically is it running? Yeah.
You're running off a port on your network, right?
It's running on my computer. So localhost is a way to refer to the computer, the current computer. So it's not running remotely, it's running locally inside Visual Studio. 44444 is a port. So when you connect to a service, you not only specify I want to talk to a service on such and such a machine, you have to say which service. And essentially the services are numbered, and the port number is what we call the number of the service. So typically web servers run on port 80. So you don't have to, in your URLs, you don't have to say connect to utah.edu on port 80. That happens by default. Sometimes you'll find servers, though, web servers that run on different ports, and then you have to specify the port. So my service is set up to run on port 44444, and it's currently running on my machine. Now, right here it says API. I'm going to click on it. And what you see here is API information for the service that I created. And the API information is generated from the doc comments that I put into my code. So that it's automatically generated. So let's look at my service. What our goal this week is to understand how to consume a service. Next week we'll see how to build a service, but this week we want to be able to consume a service. And I have an example that shows how to consume this service. So let me make this a little bit bigger here. So the model you should have in mind is, this is a to-do service, a to-do list service. So what you can do with it is you can register with it, say, I'm Joe, I'd like to use your service, and then you can put events on it. You can put tasks on it, like you say, I need to mow the yard, paint the garage, clean the bathroom. And keep track of your tasks, and you can check them when you're done, you can delete them. And you can look at other people's tasks if you want to. So the API allows you to do that sort of thing. And we're going to see how to write a GUI client that interfaces with this service to make it more convenient to use. So we're using REST, and you can see on the left here all the service endpoints that there are. So these are called endpoints. You can see we have a post request you can make to register a new user. And over there it describes exactly what happens. There is a post request. You can add an item to your to-do list. There's a put request where you can mark an item completed. There is a delete request where you can delete an item. And there is a get request that will show you all the items on the to-do list. So those are the endpoints of my service. And you can think of these, and it's really profitable to think of these as just method calls you can make. You just have to make them in a different way than you're used to. And you're making a method call to a server somewhere. So let's look at register user. It says registers a new user if either user.name or user.email is null or is empty after trimming, responds with status code forbidden. Otherwise creates a user, returns the user's token, and responds with status code OK. So what are status codes? Yeah?
Just basically what the server will tell how the action would.
Okay, so when a server responds to an HTTP request, one thing it sends back is the status code, which tells you what happened. And OK is 200. It's the mnemonic for code 200, which means things went OK. Forbidden is something, I forget, 400 something. And so this is just telling you you get information back. Now, if we click on this, we can get more detail. So you can see you don't put any information in the URI, in what I would call the URL. So it's just the URL you use is just to-do/register user. But you do encode in the body of the request. You put an object that has a name property and an email property. And it even shows you here, if you're using JSON, it would look like that. The object would look like that. If you're using XML, it would look like this. If you're using this format, it's saying I can't support that format. But my server, you can use it. You can send it either JSON or XML, and it'll be happy. And it's just showing you how to format the request that goes in the body. And then down here it tells you what you get back is a string. It's a token, a sort of security token, if you will. In JSON, what will come back will be a string that looks like that. In XML, you get that mess. You see why people use JSON instead of XML. Okay, so this is the documentation for that particular endpoint in the API. Now, when you're trying to understand an API, the thing to do is to go play around with it. So let's go to the advanced REST client here. Okay, and let's see what I'm doing. I have created a new request here. I picked post because the documentation says this is a post request. I'm contacting http://localhost:444444. So all the requests will start with that. And then where did this come from? The to-do/register user. Right? That was the endpoint in the API, right? So I just pasted it in here. I have to specify some headers. And so what I say is that what I want to get back is JSON, and what I'm sending is in JSON. And you got your choice. I don't know why I put text JSON one place and application JSON the other. They're interchangeable. So I'll just change that to application JSON. So I'm telling it here, anything I send you in the body, interpret as JSON, and what you send back to me, it better be in JSON. And so I set the headers. I got to create the body. The body contains the JSON, for the object I'm sending. So I'm sending an object that has a name field, Joe, an email address, which is a string. And now I'm ready to send it. So I say send. And what comes back is OK. And this is down here is the string that came back in the response. That's my sort of a unique identifier. I've sort of just registered with the service. So that's, you can experiment with an API and see how it's supposed to work. So first step is to experiment with the API here. Then you can start writing code to do this for you. Yeah?
How'd you set that up in Visual Studio?
Set what up?
The
Advanced REST client?
service, yeah.
Oh, how to set the service.
Yeah.
I created a certain kind of project, and
Are you just going to post that on the...
yeah, the code is posted, and we'll discuss that next week. Yeah.
Sorry, so you were saying that the port number, is the port number just the path to that specific service on?
Well, you can think of the port number as the unique identifier for the service on a computer. And I just picked it. So that's just when I wrote the service, I decided mine would run on port 44444. And as long as someone else doesn't make the same choice on the same server, we're okay. So this is where we're headed. PS9, so I have a different API I'll show you next time for a Boggle server, the word game Boggle. So PS9, you will write a client for the service I'm going to give you. So you'll be able to play Boggle with other clients. Then PS10, you will write a server. You'll write the service yourself. It'll work just like my service. And we'll do that in two phases, PS10 and PS11. There'll be 2 steps. And PS12, we'll talk about when we get there. But today, we want to see how you actually write a service to consume this API. So let's take a break, and then we'll see that. All right, let's play around with this a little bit more with the API. So I'm going to go back to the API, which is right there. And let's see what else you can do. I just registered myself as a user. Now I want to add an item to the list under my name. And so that's another post called to-do/add item. And let's see what it looks like here. There's no information passed in the URL, but there is an object in the body of the request that has a user ID. That's the token that was returned by the previous post request, and description of what I want to do. And here's some there's the example format. User ID, something, description, something. Okay? So let's try doing that. So I got some stuff to remember here. Post.todo/add item. Okay. So go back to here. And first thing I'm going to do is copy this, because I'm going to need this token. That's my user ID for the next request. So I'll copy that. Let's make a new tab here. So I got to do a post request. HTTP, so what is it? Localhost. /to-do. Oh, I forgot what it was called. Add item. Okay, so we got to do that. We need to set the headers to tell it what to expect. So let's do content type is going to be no, that's not working. Yep, application says JSON. And what was the other header? I've already forgotten that. Content type is what they're sending, and we won't accept. Okay. Okay, so we got to tell it we're communicating using JSON. And now I'm going to have to go add something to the body. So that was, let's see. User ID was that, and description. Mow yard. No, not very good there. Okay, so I've sort of told it what goes into the request. So I should be able to send this, and it should add. Okay, we got an OK back, and it gives me back the ID number of the task that I just added. And I could use that elsewhere in the API. And just to show you that it works, let's go change these headers here. Okay, I'm going to send it JSON, but let's say I want to get back XML. Let's see what happens when I do that. Okay, and you see what I got back is that XML right there. So I can control what I send and what I receive. So we could explore the rest of the API like that, but presumably you get the idea. To use it, you've got to know what method. You have got to know what what the endpoint's called. You have to set a couple headers, and you got to send information either in the URL or in the body of the request, and then you get information back. So if we go look at one last time at the API, let's look at one more. Look at this one here. To-do/mark completed /item ID. So what does that notation mean? It says marks an item as completed. If item ID is unknown, responds with status code forbidden. Otherwise, marks the item as completed and responds with status code OK. And it says the parameter, URI parameter is item ID and body parameters, none. So what's going on here? How do you use this endpoint? Yeah.
So we had the item ID that we got from the previous request.
Mhm.
All we're going to do is just paste that off the end of the URI.
Okay. So it's saying put the URI, put the ID number of the item right there in the URI. So that's just another way that you can send information into the server. So let's try that. So I need to copy this because it's going to show up. And I'll just change this one. We'll do a put. We'll do mark completed. We will put the item number there, and then the body, we don't need anything in the body anymore. I don't think it much matters. I'll just delete it, and we send it, and we get back a 204, which is another way of saying okay, I guess. Saying okay, and plus there's nothing to send back. There's no data being sent back in the server. Yeah.
Why have two ways to set parameters to the server?
Okay. Why have two ways to send parameters to the server? Well, with a GET request, there's you can't use a body. You have to use a URL. And as for the others, that's just how REST has grown. That's what people are used to. Some things they like to, designers want to put in the URL, others in the body. Yeah.
Is there any problems with having in the header saying that you're sending JSON? Or
Oh, that I expect JSON back?
yeah.
Yeah, that's just saying if you send something back, put it in JSON, and there was nothing to send back.
Well, I meant with the put request there. Is there a problem with having the headers like that, or?
No, it was fine. Now, if I do something like I mess up, or I'll put an X there so it's no longer a valid code if I do a send. Okay? So this is an interesting thing that I remember I wanted to show you when it happened. When you're running in debug mode, which I am, if a task dies, so there was a separate task in my service, which the way my service is implemented, it throws an exception that's called when it needs to when it needs to return something other than OK. And so this is actually my service code, and it's telling me that it didn't kill the application; it just broke in the debugger. It entered a breakpoint in the debugger for me to debug it, and that's kind of annoying because the unhandled exception was intentional. And so what I can do under exception settings, so this won't happen again, is I can say, when you're debugging, don't enter a breakpoint when this kind of exception is thrown. And then I can just tell it to continue and it won't bother me anymore. And so, so what happened here? I was expecting a different response code back. It said the requested URL can't be reached. Yeah?
The service terminated while you were sending your request?
Well, no, the service didn't terminate. The service is still running. Close, yeah?
Is it because we requested a URL that doesn't exist?
No, the URL existed. Yeah?
Is the service not throwing back a forbidden? Is it just stopping?
Well, let's try it again.
Was it
This time I got it back. 403 forbidden. Yeah.
because you went into debug mode, the initial thing timed out?
It timed out, yeah. So what happened was I was in debug mode for so long that the ARC here just timed out the request and said I couldn't contact the server. So you'll see this when you're writing multi-threaded programs, that when some thread ends, some task ends with an unhandled exception, normally that doesn't affect your program at all. In some circumstances, I should say, it won't affect your program at all. It won't cause your program to crash, but it may cause the debugger to enter a breakpoint. And so what I did was just turn that off. The other option is just to not run it in debug mode. And then you don't have to worry about breakpoints. Okay, so there's 3 examples of using the API. So you get comfortable with the API, and then you can think about writing code. So I'm going to leave the server running. So this is my server code. If you want to play around with this, what you have to do is bring up the server project, it's to-do list server, bring it up in one Visual Studio window and just run it. And then your client code you have to bring up in another Visual Studio program. So we'll just let this run in the background. And here is my client code. So the server will do its thing, and we'll write client code over here to use it. So let me start by making sure I'm in the right spot. I was making some changes before class. All right, so I'm going to run this and show you my client. Now my client is nothing to brag about. I just wrote it quickly one day before class, and I wish I made the font bigger, but it didn't. So I'm going to get it a little bit darker so you've got a chance of seeing what's going on. This is my client, and if I want to use it, I have to register. So I come up here and I say Joe, and it doesn't require names to be unique. Joe's already registered. So I'm going to put in some fake email address, and I'm going to click register. So what happened when I did that, you suppose, when I clicked register?
It got the name and email sent out.
Okay, so it pulled, there was an event that happened. It pulled Joe, it pulled the email address out of those boxes, and then it composed a post request like we played around with in the Advanced REST client, and it built the object, the JSON object, out of Joe and the email address and sent the request, and what came back was Joe's ID number, which the client now has saved away somewhere for future use. So now when I want to go and add a task here like mow yard, and I say submit task, what's going to happen?
It'll make a push request for that task.
Okay, we played around with this in the ARC. It's going to get the task description out of that box. It's going to get the saved ID number that was saved from the last request, and it's going to compose a post request to add a task to the list. So I submit task, and then it shows up down here. Now, let's add another task. Mow yard, paint garage. Okay, so now it shows two tasks. So what's happening is every time I change something, it refreshes my display of tasks, which, by the way, is seriously broken. I don't know, if you add too many tasks, it just stops working very well. So don't model your clients after mine. Where does it obtain the tasks to display? Yeah.
From the GET request.
Right, so there was an API endpoint, a GET request that you can ask for tasks. Now down here I can say, show only completed tasks. So if I click it, no tasks. Again, there's a GET request where you can say, just show me things that have been completed. I can say, show tasks for all users. And now, why do I have 3 mow yards up there?
Other people mow their yard.
Because there are other users that have put mow yard on their task list. And they're seeing all the previous users that have added this. So it's a stupid thing. You really don't want to see other people's to-dos. It's kind of not very private, but anyway, I wanted to, that was my only idea. Okay, you can see that just looks all wonky. Now I can click here and mark done. That results in the API being told that that the task is done. Or I can delete a task. The API is told to delete a task. So every action I take in here turns into one or more calls to the API to do what needs to be done. So fundamentally, this isn't any different from your spreadsheet. Your spreadsheet, you had a controller that talked to a view. I have a controller that talks to a view. Your spreadsheet controller talked to a model. My controller is talking to a model, but where's the model? It's the server. It's the service. So it's just a little more involved to actually communicate with the model. It's running in a different process, possibly on a different machine over the network. So let's see how to do that. So I'll kill that so we can look at the code. And you know how to set up the GUI. You have some experience anyway. And I've got 3 controllers that we'll probably just look at the first one today. And let me increase the font size, and we'll be off to the races. Okay, so here's my controller. it has a reference through an interface to the view. And let's see what else it has. It maintains a little state, this controller does, so I guess I was a little bit sloppy with it. It maintains the ID number of the currently registered user. It has a list of all the items that are currently displayed. It keeps track of whether it's supposed to show only completed items or all items, and whether to show all items or just the ones that are owned by the current user. That's a little bit of state. I guess I could have created a separate model class for it, but I didn't. Right? You can see here I'm hooking events into view, so I know when the cancel button has been clicked, the register button, the submit a new to-do item, a delete an item has been clicked, the done button has been clicked, and that event means that I need to redisplay all the tasks. So let's look at how one works. Let's look at register, because we played with register in the advanced REST client. So what I do here ought to be familiar to you. So register takes in, this is handling an event that's passing in the name and the email from the view. And this is a little bit of view stuff. I turn off the controls while I'm dealing with this request. I create a client. We can look at how you create a client in a second. What's happening here? I have to say that I could not believe it when I first learned that Microsoft had something called an Expando object in their .NET API. But indeed they do. And Expando objects are actually pretty handy. So what do you think's an Expando object? Yeah?
Is that maybe a way to represent a JSON object?
We're using it. It's not a JSON object, but we're going to turn it into a JSON object. So it is a convenient way to build JSON objects. Yeah?
It's an object that can start more primitive and grow in complexity.
Right, so it's an object. Notice we created this Expando object, and we're setting its name property and we're setting its email property. But it wasn't declared to have any of these properties. So you can set any property you wish, right? So I can say user.hello, and it's happy. And then there's a method we'll see down below that will turn this into a JSON string. So otherwise, if we didn't have Expando object, for every kind of payload we want to send in a request, we'd have to declare an object, a class that had exactly the right properties. That'd be kind of painful. Yeah?
What's the dynamic keyword?
Okay. The dynamic keyword, that's another thing. We talked about it, but it's been about 3 weeks. So what's the dynamic keyword? Yeah.
Creates a variable object, or creates an object that can be anything. It can store a string,
Okay.
and an int, and then an object, or
Right. So it means you can store anything you want into that variable. So I can say user equals new Expando object. Now I can say user equals 17. It's happy. But now if I say user.name equals some string, it's still happy, but what's going to happen when I run the program? I will get it's not a compiler at that point. I'll get a runtime error that says, no, 17 does not have a name property. So dynamic just says, you can do anything you want with this variable. The type checking will be done at runtime, like in Python. So you're completely flexible about it, but if you're not careful, you end up with an exception at runtime that says you used it incorrectly. Yeah?
Would this work if we declared user as a var?
Okay, so if we do var, let's see. Okay, let's see what the error is. Expando, yeah, it's just not, it doesn't work with var. The thing about var is, var still does type checking. But var says, when you use var, the compiler figures out what type you meant and basically substitutes it. Whereas dynamic, it doesn't, it just makes sure you use it consistently at runtime. So they're different things. var just saves typing. Dynamic's a different thing altogether. Dynamic. Okay, so we've created that object just so we can turn it into a JSON later. So we got that object. It's going to be the payload. So here's the request. Let's see. So user is that expando object created. So there's a method called JSON_convert.serializeObject. So serialize means turns it into a string. And then I have to encode that string in order to send it up, to put it in the web browser. So there may be some, to send it in the web request, there may be some characters that need to be encoded in a special way. Well, it has to be represented as bytes, I guess is the right answer. So what this does is it takes the JSON string, encodes it using bytes, using the UTF-8 encoding. That gets turned into a string content object. So that's a mouthful right there, but basically that's all boilerplate. You just put the object you want to convert into a JSON string there, and that gives you a string content object that you can use. So we do that, and then we make a post request to URL register user. We give it the body and what do you suppose this method does right here? You can ignore the async part. What does
Sends out
Yeah.
a post request.
Yeah. It sends out a post request, and then this dot result gets the response back, which we store here. So that right there is making the web request for us. So what we do is we set up the request, we make it, we get the response back. Then we look at the response. The response will have, we can ask, was the code that came back with the response, the status code, was it a success code? Success code is anything that starts with a 2. So if it was successful, we do one thing. If it wasn't successful, we display an error message. You know, we say, I got a status code I wasn't expecting. Again, not a very good design, but works for an example. If it was successful, what's happening here? Yeah?
It's just reading it.
All right, so we're taking the response and we're extracting the string that was in the body. We turn it. You know, we expect the string to be the JSON version of the body was the JSON version of the string. So we use JSON_convert.deserialize to turn it into a C# string. That's our user token. And then we run an event on the view to tell us that it was successful. Okay? So, you know, there's not a lot of code there, but there's a lot more code there than it takes to make a method call in C#. Look at all the work we have to do. We have to package up the parameters into an object. Well, you might have to do that in C#. So we're building the object we want to pass as a parameter. But then we've got to take that thing, turn it into a JSON string, turn that into a bunch of bytes so that we can send it along with the request. And then when we make the request, we have to make it over the web by giving a URL. And then when we get the response back, we have to deserialize it and turn it back into a string. So serialization talks about taking an object, turning it into a string. Deserialize is going the other direction. So there's a lot of stuff that you have to mess around with. But it's just a different animal. When you're lots of things, when you call a method in C#, you don't worry, oh, this method call may not succeed. It may not be able to find the method. Right? It always finds the method. When you're making a call over the web, you know, the server may be down. So, you know, you can get an exception that says, no, I couldn't reach the server. So there's just more things can go wrong. Yeah?
Deserialize goes from a string back to an object.
Yeah, in this case, the object is a string that it's going back to. But so serialize goes from a. Well, let's go back to the code here. Serialize was taking a C# object and producing the string form of a JSON object. Deserialize goes backwards. So if we took that thing out, highlighted, and deserialized it, we'd get back that thing right there. They're just opposites. Okay, so that's that. So I'm going to show you another example here. Let's see if there are any questions about that. Yeah.
If you scroll down, why did you do the view dot enable controls and view dot not enable controls at the top?
Okay. So my idea was I don't want to have multiple requests going on at the same time in my client. So when you say register, I basically freeze the controls until I get a response back.
Then it's like you can't push any buttons, you can't do anything,
Yeah.
can't close it. Okay.
Right. Now, having said that, I do want to be able, let me show you a little feature I have here. Let's see, there's the server, here's the client. So I'm going to run the client. And I'm going to register Joe again. Different email address. Register. Now, if you use the task STALL, stall, I've got the server written, it will sleep for 5 seconds before it responds. And so I'm going to submit that task, and you can see that it worked. Oh well. Let me try again. No, it's okay. Well, I'll have to. There's a topic for next time anyway, so I can figure it out. But what I was trying to show you is that if I do this, it freezes up all the controls for 5 seconds, even this cancel button. So we were going to work on that, but I'll figure out what I did wrong by next time. I don't know what I did with stall. Okay. Any other questions? Yeah.
So that post async method, is that like, I guess, resolving a promise? So does that wait until we get a response back from the server?
Yeah, so this is something else we'll talk about next time. So there is a method called just post. To use post, you would do it this way. I think. Maybe there's not one called post. I take it back. So what post async does, there's a way to use post, well, post async returns a task. So when you call client.postAsync, what it returns is a task that's job is to go make the call to the server and get the response back. And then that task will produce as its result the response. And so by writing the code this way, I'm basically creating a task and then blocking until it's done and then getting the result out. What we'll do going forward, the next version of the controller will actually separate it out so that it creates the task, and then only after the task is finished does it pull the result out. And that's useful from the standpoint of being able to cancel things. But I'm going to get ahead of myself here. So, but for right now, you can just look at this and say this combination here makes a method call to, makes an endpoint, goes to an endpoint on the service, gets a result back, and gives you the result. And in reality, what's happening is a task is created, we're blocking and waiting for it and getting the result back. So we'll play around with that next time. Any other questions before I scroll to another method? Okay. Submit. That's very much like the last one. Let's look at delete. Actually, we didn't play with delete. Let's look at done. Marks has done the task at the specified index. Okay, so again, this is just user interface stuff. I freeze the user interface. I create a client object. I promised we'd look at that, so we still need to do that. What's happening here? Yeah.
String dot format just takes like a string as the first parameter, and then puts whatever you have in there inside those curly braces.
Okay. So if you constantly find yourself writing code that says something like quote, string, quote, and then you plus something, plus more quoted string, plus some variable, plus some string, plus some variable. String.format's easier. So I just say mark completed slash, and I put the 0 in the braces. And then I give an extra parameter here. And the value of that yellow parameter is plugged into the string right there in place of the 0. If I wanted to have other things, I would use braces 1, braces 2, braces 3. It's just a way to plug pieces in. So given that that's what string.format is right here, what am I doing? What string am I creating here?
URL.
Yeah? Yeah. I'm creating the URL that I want to pass to the service. And what I'm doing is I'm told I want to mark item 3 in my to-do list as done. Item list sub 3 here will be the ID number for that the server knows about for item 3. And we're just building, remember, for done, we had to actually put the ID number into the URL. So we're building the URL that contains the ID number. There is no body to be sent with this particular request, so I set that to null. And then, you've seen this before, I just do put async of URL, null content, and I get the result back, and it goes into the response variable. If it was successful, I refresh the API. Now, refresh is going to cause a GET request to get updated data back. And otherwise, if it wasn't successful, I display my status code. Okay? So basically, all that code is to call an endpoint on the service and take care of things that might go wrong. Yeah?
So is it fair to compare mark completed to like a folder on the server, and then it's just accessing a certain file on that folder? Like item list index is a certain file in the
Well, I mean, you could model it that way. You can, it's just that the service is keeping track of a bunch of to-do items, and some of them are marked completed and some aren't, and we're just telling it which one to mark completed by giving it an ID number. Okay? Now, one thing that's been common in both of these is create client. Actually, so there's create client, and this is just doing some common code. So let's see what there's an object in .NET called HTTP client. So we create an HTTP client object. We set its base address to be this. So what are we achieving by doing that? Yep.
Is that getting like the base service?
Yeah, that's just every one of the URLs we're going to use for endpoints starts with that. So we just set that as a base address, and then when we call a particular service, we just give the rest of the URL. Yeah?
So like so when you said you could set it up that way, like you're paying like a certain file on your server, so you're saying like you could either have like that address bring you to like an executable, which is your service, or you can have it like actually be a file on your computer.
When you say, I'm not sure what you mean by file on the computer.
So like he was asking about like by using like the backslash or the forward slashes, like
Oh.
it kind of looks similar to like a file path on your computer.
Yeah.
So that's not necessarily what it is, but you said it could be.
Yeah, that what I meant when I was saying, I think his question, at least the way I interpret it, was different.
Right.
Yeah, this looks like a URL. And essentially, when a HTTP server gets a URL, it looks at and decides what to do. And, and so if I took this, let's just go type this into a web browser and see what happens. Well, I know what'll happen. Because when you type something into a web browser, it's automatically going to be a GET request unless you're submitting a form. So I can put some garbage up here and submit it. And, and it doesn't like it for whatever reason. Because it was a GET request. It wants a put. But if I do this, I do get a document back. So it's just up to the web server to interpret the URL and decide, are you trying to run a program or are you trying to get a file? And it does what it has to do. Okay, so we just set up a common base address there. And then, we always want JSON back, so I'm setting that here. And then we create the client. And then you run methods against the client, the post, the put, the get, so forth. So last thing, let's look at that GET request. So refresh, its job is to go out and get an up-to-date list of what tasks are supposed to be displayed and display them. So We didn't even look at the API for this before, but you can see that it's a GET request. It starts with get all items. You plug in right there true or false, depending on whether you want to show completed tasks or both completed and uncompleted tasks. If you want to see all the tasks, regardless of who created them, you put all after the slash. Otherwise, you put the ID number of a particular user after the slash. So we're just building the appropriate URL. So if I were to go back here, since that's a GET request, that's what's going to be issued when I do this. So I want to say to do, I want to say, what was it called? GET. Get all items. And I want to see all of them, even if they're not completed. And I'll give, it's not going to like that because that's supposed to be, well, actually, I just put all. Okay? So I just accessed the service from the web browser. And what I got back was an XML file containing the tasks that exist there. Now, why did it send back XML? I didn't ask for, because my browser asked for it in XML, I guess. Didn't ask for it in JSON. Okay? So anyway, that's what we're doing, is we're composing a URL like that. We issue the GET request again with GET async. We get the result back. And it was either a success or it wasn't. If it was a success, then what we got back was an array list of item objects. So let's see what we do. We deserialize it into an array, into a list of items. We iterate through the list of items. And each item has a description that we pull out, a completed, true or false, is it completed that we pull out, a user ID that we pull out, an item ID that we pull out. So that's the beauty of using dynamic here. We don't have to know the actual type name of the thing we got back. We just know that expect it to be a list so we can iterate over it. And whatever is in the list is going to have a description, a completed, a user ID, an item ID that we can pull out. And we use that to update the view. Yeah?
So what sends the header information? Is that wrapped in a response, or like is that something you could apply?
The header information is set back in create client.
Okay.
And the only header I'm setting is the accept header right there.
Okay.
Okay, so I don't know if this looks easy or hard or mysterious or what, but it needs to become non-mysterious because your next assignment next week will involve creating something like this to play ball with. So, see you next time.
Yeah, we're getting